We're doing operations with polynomials, and we are dividing polynomials, and now we're going to use the remainder theorem to evaluate polynomials. And basically, the remainder theorem says when you have a function, in this case f of x, divided by a binomial, x minus r, the remainder is the value of the function evaluated at r. So if we look at over here, we have some function, some polynomial f of x, divided by a binomial x minus r. Remember, we use the zero product property to figure out what the what the answer to this would be, or what the zero would be. And so we solve that. X minus r equals 0. Add r to both sides. X is equal to r. So we can use synthetic division, where we substitute r and we divide that polynomial using synthetic division, and the remainder ends up being whatever our function was evaluated at r. So we're going to do an example here, and we have the quadratic function x squared plus 6x plus 5. Remember, our coefficients are 1, 6, and 5, so we put those into our synthetic division bracket, and we're trying to evaluate it at 2. That was our r over here. In synthetic substitution, we're going to add down and multiply diagonally. So 1 plus 0 is 1. 2 times 1 is 2. 6 plus 2 is 8. And 8 times 2 is 16. 5 plus 16 is 21. So this is the solution to the function evaluated at 2 is equal to 21. And we can do a quick check here. So we have the function, and we're going to evaluate that function at 2. So we substitute 2 in for all the x's. So 2 squared plus 6 times 2 plus 5. And we get 2 squared is 4. 2 times 6 is 12 plus 5. And then we get the function evaluated at 2 is equal to 4 plus 12 plus 5, which is 21.